Hi all, welcome to the video lecture series for the subject Mechanics of Fluids. By this video lecture series, we are actually planning to complete all the topics for the subject as per the syllabus by KTU. Now in this first video, we are discussing about some important concepts and introduction to some of the basic concepts for the subject fluid mechanics, which is otherwise known as mechanics of fluids. And these concepts will act like the prerequisite for the subject. We have also studied up some subject in our first year, which will also act like the prerequisite for the subject. But some concepts, important concepts, need to be added before the actual syllabus of the subject. Okay, before we are going to the actual syllabus of the subject. So without further ado, let's discuss about the concepts. So introduction to the subject. We all must know a definition for the subject. So as a definition, fluid mechanics is the branch of the science which deals with the behavior of fluids. Fluids are considered to be liquids or gases at rest as well as in motion. See, just connect this sentence with our engineering mechanics. We have studied engineering mechanics in first year. Okay, we have studied that in our second semester, I think. So in that subject, we have studied about only solids. If you remember correctly, we have considered only solids in that subject. But we all know that our states of matter. Okay, we all know our matter is made up of different states or phases, which are solids, liquids, and gases. Okay, so that was a limitation of the subject, engineering mechanics. We can only study about solids in that subject. When the case of fluid, which is a liquid or gases, when a liquid or gas is considered, we can apply some of the engineering mechanics concepts. But when we are studying in detail about this situation, we need to go to another subject. We need to go to higher subjects like, or in detail subjects like fluid mechanics. Okay, so that's why we are studying this subject in our third semester. We will be studying more about fluids in higher semester courses also. So that's why we have specifically mentioned here the mechanics we are dealing with is fluid mechanics, which will be dealing with liquids or gases. Now this is a branch of science which deals with statics, kinematics, and dynamic aspects of fluids only. We will not be considering the case of solid here because we have already dealt with that in engineering mechanics. Also, we are studying the subject mechanics of solids along with this fluid mechanics in this semester itself. So we don't need to analyze solids in this subject. Okay. Now, what is statics? We all know what is statics. We have studied in mechanics, engineering mechanics. So that concept is applied to fluid. Then this statics is called fluid statics, study of fluids at rest. Okay, when they are not moving, when fluids are not moving, and we are studying them, then it is called fluid statics. When the fluids are in motion, but we are not considering the cause for that motion, then it is called fluid kinematics. The study is called fluid kinematics. Here the cause for the motion is pressure force, and we are not considering that pressure force. Then the study is called kinematics, specifically fluid kinematics. And if the pressure forces are considered for the fluids in motion, then the branch of science is called fluid dynamics. Okay, so these are three important areas which we will be covering in our syllabus for the subject. Now, what is a fluid? We all have to answer this question when it is asked. What is a fluid? We all know now the fluid comprises of gases and liquids, but we need to explain with a technical explanation. Okay, so for that, let us see some of the important concepts. We all know that there are three primary phases: solids, liquids, and gas. There are also other phases also which was discovered later. For example, fourth state of matter is considered to be plasma. Okay, but in engineering, in BTech undergraduate program, we will not be studying about the fourth matter, that is plasma. but the name will be mentioned in some subjects like material science and all. In some manufacturing processes, there will be welding and all. In that context, the word will come plasma. But its structural arrangement and all other aspects, its dynamics and mechanics will not be studied in BTech subjects. It will be studied in uh, advanced postgraduate subjects. Okay, so we will be leaving that state of matter from this subject itself. Now, the substance in liquid or gas phase, they are referred to as fluid. Solid will not be considered as a fluid. Okay. Now, the distinction between solid and fluid. How we can distinguish between a solid and a fluid? It is made on the basis of the substance's ability to resist an applied shear that tends to change its shape. Now, let us explain this with the help of an example. Take a cube. A solid cube is taken, and also take a container which is in the shape of a cube. Okay, and the container is open, and in the first case a solid cube is taken. Apply some pressure, apply a tangential pressure, apply a normal pressure. Okay, so different types of pressure is applied on the cube, and on the basis of the material of the cube's shape will be changed as per the value of the pressure we have applied. Okay, so that means solids tends to change its shape when a stress is applied. Okay, whether it is tangential or normal stress, it will change its shape. But the difference is that the solid will try to resist the applied shear stress or force. Okay, it will try to resist even though there's a change in shape. Now take the second case. We have taken a container also in the shape of a cube, and it is also hollow in shape so that we can fill a liquid in that container. Now the liquid is filled inside the cubical container. What happens? The liquid will continuously deform such that it will acquire the shape of that cubical container. Okay, we haven't even applied stress or tangential force or something, but it itself changed its shape to acquire within the container. So that is the main difference between solid and fluid, solid and our liquid. Okay, so here we can consider that a solid can resist an applied stress by deforming. Solid will deform when we have applied a shear stress, but it can resist the applied shear stress even though it is deformed. But in the case of fluid, it will deform continuously under the influence of shear stress. If you have applied a stress on liquid, it will continuously deform. That's why I mentioned about an example. When a liquid is filled inside a container, it will continuously deform until it acquires the shape of that container. Okay, that is the meaning we can get from that example. That is a statement from we can obtain from that example. Therefore, the fluid will deform continuously under the influence of the shear stress. Okay, shear stress is a tangential stress. If you are giving a tangential stress, the fluid will continuously deform. Okay, but in the case of solid, even though it will deform, it will give a resistance. It can resist the applied shear stress. So these two sentences are very important when the comparison of the fluids and solids are considered. Now, a fluid may be considered as a substance which is capable of flowing. We all know that fluids can flow, whether it is a liquid or gas. It can be flown. But a solid cannot be flown unless it is melted or it is converted to other phases like liquids or gases. A solid can be converted to liquid. We all know that conversion. And also a solid can directly be converted to gaseous form. Okay, we all know that from our past science days. Okay, so we are not discussing detail about that processes, but just consider fluids are capable of flowing, but solids are generally considered not capable of flowing. A liquid and also fluids have no definite shape of their own. It will continuously deform when shearing forces are applied. that can be connected with our previously mentioned example. When a liquid or gas is filled inside a container which is in cubic in shape, the liquid or gas will continuously deform until the shape of the cubical container is obtained. Okay, that is what mentioned here in this sentence. A liquid is a fluid which possesses a definite volume which varies slightly with the pressure and temperature. Now we have defined the meaning of fluid itself. Now we will be distinguishing between the liquid and gases. Okay, we are now taking the case of the solid out. We are only concentrating now only on liquids and gases. In that context, a liquid is a fluid which possesses a definite volume. Okay, liquids. Take the case of water. Take the example as water. Water. If we are taking a volume of water, for example, if you have taken 1 liter of water, its volume cannot be changed with pressure and temperature. Okay, if you have taken 1 liter of water in a container, the water's volume cannot be changed with pressure and temperature. Okay, but there is an exception. If you are giving high values of the pressure and temperature, we can change the volume. That is an exception, but generally liquids are considered to be a fluid which its volume cannot be decreased by slight variation in pressure and temperature. Only with high variation of pressure and temperature we can change the volume. With slight pressure and temperature variation we cannot change the volume of the liquid. So generally liquids are considered to be difficult to compress. We cannot compress the liquid. The word compress means we are decreasing the volume. When the volume is decreased, it is considered to be compressed. So we cannot compress a liquid. We cannot compress water. Okay, that can be taken as an example. We cannot compress water. Therefore, liquids are difficult to compress and they are generally considered to be incompressible for practical purposes. Incompressible. This word is very important. Incompressible. Okay, it means it is not compressible. Not compressible is called incompressible. But in the case of gas, a gas is a fluid which possesses no definite volume. Gas has no definite volume. If you are filling gas in a container, it will acquire the shape of the container. Okay, acquire the volume of the container. That means it will travel to all the corners of the container, all the different parts of the container. It will completely fill the container. That means the gas will expand in the container. Okay, even if no processes are given to even if no pressure or expansion is given to the gas, it will continue to expand in a container. So it has no definite volume. Also, we can decrease the volume of the gas. Okay, that means gases can be compressed also. So gases can be compressed or expanded. Okay, it will expand until it is filled in the container, or it can be compressed by decreasing its volume by some means. So generally, gases are considered to be compressible when compared to liquid. So these are important comparisons between liquids and gases. Even a small change in pressure and temperature of the gas has got significant effect on its volume. Okay, that means if we slightly vary the pressure or temperature, the volume of the gas will change. But in the case of liquid, the slight change in pressure and temperature will not vary the volume. That's why it is considered to be incompressible. And compared to gases volume can be changed by slight variation in pressure and temperature. Therefore, gases are considered to be compressible for practical purposes. For example, our oxygen, the oxygen we are breathing is compressible gas. Its volume can be decreased or increased. It can be compressed or expanded. That's why gas is considered to be compressible. Now, we will be differentiating between solids, liquids, and gases in detail. Let us see these different statements. Molecules are relatively fixed positions in a solid. Groups of molecules move about each other in liquid phase. Molecules move about at random in gaseous phase. Okay, so we will be discussing these three statements in detail in our next video. So thank you for watching.